So today's Tech Hour is fun and games with Git and Fossil. The date is the 27th of October 2022. And they're both version control systems, and they're both used to host software. Git is used to host Linux development, and Fossil is used to host SQLite, which is, I won't call it a lightweight, but it's not a heavyweight SQL database. And it has the great advantage that it runs anywhere. It's quite simple, and you can actually run it in the browser. So it means that your SQL databases, part of them can be, or your knowledge of that, can be used for local storage and on web pages, which is extremely interesting and useful. They both have different approaches to version control, but they have one big thing in common, which is they're both what are called distributed version control systems. And distributed means it's peer-to-peer. It means that in principle, what you have on your machine is equivalent to what there is on GitHub or anywhere else. So that's actually quite a powerful concept. And they both use what's called a content addressable store, which means that any piece of information that they store has a unique name that depends only on the content of the information. And it does that by a method called secure hashing, which is sort of fingerprinting. And that gives them both a large amount of power. I had intended to spend more time on Fossil, but I came up against a bug in Git library, and that took 2 hours out of my day, perhaps longer. But what I'd like to do is explain what I'm doing and why I'm doing it. I think the why is a bit hard to explain or a bit complicated. I'm interested in Git in particular as a way of dealing with large amounts of information and managing, ensuring consistency of inputs when there's a potentially large amount of data that needs to be checked. And my interest in Fossil is that it seems to have a different approach to things, and in some sense, it's likely to have some interesting features. Something that struck me is that Git and Fossil are both databases, and they're both text-oriented rather than sort of numerical data or sales record sort of databases. So it's unlike the LaTeX, Apache, MySQL, Python stack that was used for building a lot of websites 15 years ago and still used. And one of the things that I'm interested in is using version control, so to speak, for people that don't want to use version control. It's just under the hood and it does things. And one of my small ambitions is to make it easy to take notes and put the notes into version control. And as you need to organize them, they might post-it notes, so you organize them. And that means that you have your basic things, which are your post-it notes or whatever they are, and then there are artifacts, which are the organization of the more basic things. So you could think of a book as being made out of sheets of paper, and each piece of paper has got a correspondence between people is made out of letters, but the letters are then organized. And that makes a composite, and the relationship between the things is as important as the things themselves. And these artifacts, so to speak, get added later. And I'm not convinced that Git has the right artifacts for all our situations. Let's put it that way. Or that it doesn't have all the right artifacts we need. And that's one of the reasons why I'm interested in Fossil. But what I'd like to do now is put the recording on, do some screen sharing, and So let me tell you what I'm up to. I've got a fairly large vision as to what I'm trying to do with Git, and it's not traditional use of Git. And to do that, I need things other than command line use of Git. I need a programmatic interface, and there's a library called libgit2 that gives you a programmatic interface. And as time goes by, I'm mastering more of that library, which allows me to say to myself, this is what I want to do, and I will find a way to do it. So what I'm going to do is give you an example of that. So in the left-hand screen, I hope it's big enough. There's what's the word? There's an editor window, and I've got a function called add directory to object database. And I'm going to use that function. And I'll explain what I'm doing. So in the right-hand window, I'm going to make a new directory, which is where I'm going to do my work, which I will call, I'll call it somewhere. It doesn't matter what I call it. And I'm going to go into that folder called somewhere. And I'm going to create a Git directory. And it's going to be what's called bare. And it's not going to have a working directory. So all it is an object store. So if I look at what they've got in the bare directory, this is normally what you have in a .git directory. And we're going to add the contents of a directory into this object database. So what I'm going to do now is I'm going to run the folder. So I've now got this function that I defined in the left-hand editor window. And it needs an object database, and it also needs a path. Now, if I use bare.git, that gives me a repository. And for what it's worth, it's a bare repository. And it has an object database. There it is. Now, the other thing I need to do is to give it a path to somewhere. And I'm going to do that in a slightly odd way. So here I've got a path, which is where text stores some of its files. And if I put the Python matter up into the foreground, I can write path equals And now I can write and that has added all the files in that path to the object database. And it's given back this quantity here, which is the fingerprint for the folder I've just added. So let's try and do something with this. So we'll try git what is it? I think it's archive. Just to prove that I've done that. Don't want that. This won't work because I haven't properly scripted everything. So I'm trying to copy that object identifier. Copy. Paste. There it is. And I've forgotten to say that the output equals that. And I've now got a zip file that contains, so what I've done here is I've put that directory of material into the object database, and here I've extracted it out of the object database. And if we do unzip -L, these are all the files we've got. So in a certain sense, I'm proving that what I've got, I've really done. So let's see what we've done again. I'll go back to the Python shell. That was the first thing we did. We made that the path. And then we added the directory to the object database. So what we've done here is something that you often do when you use Git, and you'll do it in Fossil too, which is put a tree of files into the database and give yourself a single handle, the secure hash, the very long number, as a way of handling, as a way of referring to the whole lot. So that's a tree, and it contains blobs of data, text files, and it also contains other trees. So what I've done here is I've written a command using pygit2, which is a wrapper around the libgit2 library, that allows me to do that. Now, if we want to use Git to distribute a large number of diverse files, but maybe have got no particular relationship to each other, we're not doing version control. all we're doing is creating resources. And what I've managed to do here is write a command that will store a tree that is being read from disk and put it in the object database. I'll briefly run through what the command does. We sort of start with a dummy repository so that we have an index. And we use our existing object database as the object database for the repository. That's what we did over here when we used the bear.odb. This thing here is the thing that cost me 2.5 hours today, which is that it's a bug that whenever you create a new repository in this way, it's not empty. And so I have to clear it. And then this is the command that adds the contents of the directory to the path, to the index, and then I write it to the object database and I return the object identifier. So if you've got a whole bunch of stuff that you just want to store and you want a handle, which is a secure hash, this allows you to do it. You just say, here's the path I want to store, and it gives you back where it's stored. So that's the first thing that I've been doing. I'm going to go back here and I'm going to unzip this file. So now we've got, there we go, where did all that come from? So all of this came from the Tech Live distribution. I'm just going to go foreground and I'm just exiting from the Python shell that I had because I want to start with a clean hands. The one thing we have got here is our bare Git repository. That doesn't have to be here. It could be anywhere else that we wanted. And we've got the wibble.zip, which we unzip to get all of this. So these are all the plain macros in the Git in the Tech Live distribution. So ls here's some stuff from Don Knuth. And who knows what else there is. ls pytech, I don't know. There we go. So it's bunches of files, and we're not much interested in what the files are. But what is interesting is all these files are coming from different sources. And one developer is developing CWeb. And they may be using their own version control system, which might or might not be used Git, and they'll have their own repository. And PGF is another piece of software, and it will have its own developer. So what we've got is a sort of package index or something more like CTAN than an individual developer's thing. And I'm going to show you something quite interesting, which is I'm going to create what's called an orphan branch, if I can manage to do it right. So you notice it needs a tree. I think I'm just going to go ahead and do it, and then we'll see what, and then we'll explain what happens, what's happened. So we're going to start with this bare repository, as before, and we're going to create a tree. So we're going to add the directory to the object database, and it's going to be bare.odb ODB. And the path is going to be one of the paths that we had before. So this might be VNTech. And let's have another one called base. So those are the names, if you like, for those particular objects. Now we're going to add an orphan branch, and it's going to be the bare repository, and the path in one case will be base, and we have to describe what the this is a commit message, and we have to give the tree, and it's going to be this long number here. And this might work. Ooh, not defined. Sorry, we have to do this. And at last, we get it right. No. Hang on, face.
Is that long hexadecimal string acceptable there, or was it expecting a quoted string?
That's oh, you know, I think you're right. Yeah. Type error. So having done that, let's remove my previous fix. Okay, that's created an orphan branch. And let's just have a look at that branch. So there's a branch for the repository. I'm going to do something a bit drastic here, which is I'm going to remove that base folder. So now if we do ls base, there's nothing there. And what I'm going to do, if I can manage it, is I'm going to work tree add base okay. Now something very interesting is happening. So here's our base folder. And it's got a little .git folder inside it, which we didn't see before because it begins with a dot. And this .git folder is simply a pointer to a location in our bear repository. But the point about this is that we can now do git log. And that's the whole history. The commit message is the commit message I gave earlier. So what this means is that we have a folder in somewhere that contains the base folder, and that base folder is itself a Git repository or behaves like a Git repository. But all the stuff is being stored in a separate place. I'm going to go back to here, go foreground. Now, that was the base thing that we added. And here is the VNTech directory that we added. And we could do exactly the same thing. And thank you so much, Nelson, for teaching me to quote. Okay, so that's also got a commit message. So let's do a Control Z. So now we've got a base branch and a VNTech branch. And we'll do exactly what we did before. Except there's VNTech, whatever it does. I'm going to remove that whole folder. And then I'm going to put it back as a Git repository. So if I do something like echo hi there into me.tech, I need to give a message, sorry. Okay, so we're in the VNTech branch, and it's got the original commit and the stuff that I've added. Now, if we go up to here and go to the base branch and do git log, we've got we haven't had the commit. So these two things are completely separate, completely independent. And the way this is useful is that it's good for the small stuff that is independent. So I have, or used to have, lots and lots of little Git repositories. You know, I like to keep my stuff in Git. I like to have it under version control. But I don't want unrelated stuff to be tied together. So if I automate this process, so if I go over to the editor screen on the left-hand side, I've created here in about 50 lines some tools that manipulate Git repositories in a sort of non-standard way. They allow you to add content to the database and to determine the hash for stuff in a folder, and it allows you to create branches. Now, if I've got 500 customers and I have correspondence with 500 customers, I maybe want to store the stuff in Git, but I don't want one Git repository that holds all the stuff, so to speak, together. I'd like, for example, to say to somebody, you deal with this customer, and when you finish, send me the stuff you've done. It's like taking a book that's bound up, and instead of having a book that's bound up, you guillotine it along the edge, and then you get individual pages. And so you have a whole bunch of individual pages, which are, so to speak, loose leaf in a ring binder. That's perhaps the way to describe it. Is we used to, here's one sort of book for writing in. I don't suppose you can read this because my writing is very, very small. But you can see there's many, many blank pages. And when I do this, they don't fall out. Whereas the other thing you have is the ring binder with the punched sheets of paper. And you print the stuff off on your laser printer and you do the whole punch, and then you put it in your binder. I've got an example probably here. Yeah, this is just a ring binder full of stuff. You can see the rings, and it's individual documents that have been assembled together. And in some cases, the assembly is as important as the documents. The creation is important of the documents. So what we've got here is a use of Git repositories where, well, I'll show you what it does, you see, which is that here I created a work tree called VNTech. Now, it might be remove, or I think it might be remove. Sorry, I have to go up a directory. Okay. VNTech has disappeared. It's still in the branches, it's still there, but it's not checked out. And branch is the correct word. But now it's there. And now it's gone. So this is as though you've got a filing cabinet. And in the filing cabinet, you have folders. And this situation allows you to check out a folder or yeah, check out a folder for working on without checking out all the folders. So if we look at this situation here, and this is just plain doctech, which is small, we've got all the stuff here coming from different sources. And Metatech, for example, whatever that is, has its developer. And if the developer's using Git, then he can have a Git tree. And we can incorporate that Git tree into what we've got here without it interfering with any other, because it's in a completely different branch. And it's not only that, but the two branches have got nothing in common. Here, the command is called add orphan branch. And when you create a commit, you have to say what the parents are. Well, here, the parents are empty. We don't have any parents. It's an Adam and Eve branch, if you like, rather than an orphan branch. Would you describe Adam and Eve as orphans? Not exactly. But anyway, this thing doesn't have any parents, and so it can, so to speak, be moved from one repository to another. So this is a way of treating your Git repository more like a loose ring binder, where you can take out individual pages and put them in a different Git repository and develop them there. Or you can say, okay, I'll let you clone this part of the repository because you need to work on it. Or you can say, I'm going to add your stuff to what I've got, and you can add it completely unchanged because it's like a loose ring binder. So I should probably stop at this point. The thing that I found most exciting, apart from finding this bug in libgit and not being completely defeated by it, I was defeated by it for about 150 minutes, but I wasn't completely defeated by it. Apart from that, the thing is that I had a conception of what I wanted to do with Git, and I was able to do it. And that to me is the thing that is sort of opening doors, is think of Git as a distributed peer-to-peer content addressable store. Think about the things you want to do without worrying about how you're going to do it. And if what you want to do makes sense, then you can find a way of doing it, but not using the traditional Git command line tools, because they don't allow you to do this sort of stuff. But this programmatic interface provided by PyGit2 and by libgit allows you to write code that is really, really powerful. So the code here is handling the interface with Git. You'll write other code in Python, which is considerably more standard, which is interfacing with the folder you've got. So if you remember, I got all of this stuff from a TechLive distribution. So the little folder I've written on the left-hand, the little file I've written on the left-hand side, when driven by standard directory listing stuff that Python allows you to do, will allow you to create a Git repository that is manageable for TechLive. And when I say manageable, it's broken up into pieces. So each particular project, or each particular folder, which isn't exactly the same as a project, you can choose which folders go into a separate development area, if you like. And that also allows you to play around quite flexibly with versions. So you can say, oh, well, let's try having this version of Lambda lists and this version of WASY. And you can simply check out the different versions as you go along. So if we CD, it's disappeared now. So here we've got two versions. Here's me.tech. Here I think we can do a git checkout. Well, I think 1986 will do it. I'm just using the sorry, I've got into somewhere which is outside my Git knowledge. I don't know where I am at this point, so I'll forget about that, and I'm going to stop screen sharing, and we can have a conversation.
So, Jonathan, am I correct in assuming that wherever you've used path here, this could be a local file path, but it could also be a URL at your collaborator site? Is that correct?
Yeah, well, at the moment, well, yes and no. Git can do transport from repository to repository via URL. So the peer-to-peer is from one repository to a different repository. Here, these operations are taking place within the same repository. And so the answer to your question is both yes and no. Technically, the answer is no. Morally, the answer is yes, in the sense that anything you reasonably wanted to do, you can do. So let me backtrack a little bit. You can't communicate trees from repository to repository. Git could be set up that way, but it isn't. You have to reference the tree, and then you can communicate references from repository to repository through the network. So you can push and pull. You can push and pull anything that's got a reference. So I can show you that. cd ... ls. Okay. So if we look at refs,
well, I think we need a screen share again.
Oh, sorry. Yes. Sorry. Thank you. You're really very helpful. Okay. So here is my Git repository, and anybody that's working on the same project as I am has a similar Git repository, and it's got in it a folder called refs, and part of that is the heads, and those are the two branches that we've got that we've checked out, and these are pointers that move. And then the other one we've got is tags, and we don't have any tags. Yeah, you see, here's tags, and tags is empty, but I can tag things as well. So there's a git tag command that will tag something, and then I can push that tag to another repository, or another repository can pull it from me. So once you've given it a human name, you can move it to and fro. Is that okay, Nelson?
Yes.
I guess this is less impressive than I'd hoped. The thing that I am impressed with is that I've been able to make progress with this, and in a sort of fairly coherent way, write code that allows me to move along towards my ambition. So this would allow me to write ordinary Python code that doesn't know anything about Git. This is the stuff that interfaces with Git, but I can write Python code that just knows about the file system. And it would create a Git repository for me that would have all the content of the macros folder in a TechLive distribution. As in, if I remember how we got here, so here we have a TechLive distribution, and I just used the plain stuff. I just got the plain stuff and put it into Git. I could take all the stuff we're interested in and put it into Git, and so to speak, burst it so that it's not one big monolith. It becomes a large number of independent things that can be dealt with independently. And then if somebody who owns one of these things, who's the developer of one of these things, says there's a new version, I can put that new version into the repository as if it were in his own private development area. So it's a way of sort of doing parallel development without a monolithic sort of structure thing. And it would allow people to, so to speak, run their own CTAN. I know that sounds a bit bizarre, but something like that. And doing this stuff with Git command line is really painful, if not at all, if possible, if it's possible, it's difficult. It's probably impossible. It turns out this adding the orphan branch is quite difficult at the command line, for example. So that's what I'm pleased about, is that I'm much closer to being able to build what I want, and things I hope that other people want. And in a sense, your Git repository is not, here is my project, it sits in a Git repository. Here's another project I've got, it sits in a different Git repository. You say, here is all my work. It sits in one Git repository, and it has a large number of independent parts that behave as if they're independent Git repositories. And I can check out the stuff that I'm working on, and then the stuff that I'm not working on, I can, so to speak, check it back in again. So I can pull out a work tree for a folder, and when I finish working with it, I can put it back again. So that you only have to have as files on disk the things you're actually working on. That's one way of looking at it. That's what I meant by having hundreds of customers. So maybe you've got 100 customers, and every time you do work with the customer, you create the work tree for that customer, do the work, and then you delete the work tree for that customer, and it's all in the Git repository. And if you ever want to deal with it again, you bring it out again. RCS has a similar sort of thing with checking in and checking out. One of its default behaviors is when you check in a file, it says, okay, well, you've checked it in, so I can remove the working file. And often that is the right behavior. I'm not saying it is always. So I'll stop. Somebody else will say something. I'm going to stop the share too.
I've been an RCS user for several decades, and I never use it in a mode where once you check something in, it's gone from the working directory, because I want to use it to keep a record of changes, but I want the working directory always to have the latest version, so that when I'm building software, it's there for the compiler. And so my check-in commands always use an option that says, put in the changes, but bring it back out so I have a writable copy.
Yeah.
And I've seen other packages where people have assumed that things are kept inside the Git or RCS repository, and then they're checked out on demand. But to me, that leads to a very confusing situation. I'd rather just have the revision control system invisible to all other tools that operate on the software, including compilers and text editors and so on.
I quite like to. I'll show you. I mean, physically show you. This is an envelope that's containing the mathematics I'm writing this month. It's all this month's work, and it's all on individual sheets of paper. And there's probably about 40 of them today, this month so far. And when I'm working, they sit out on the desk. And I look at the ones that I'm interested in, and I'm not interested in the ones from September most of the time, or earlier. And when I'm not working on them, I put them in the envelope, which keeps them safe and out of the way, and they don't clutter things up. So when you're reading a book and you finish reading it, or you finish reading it for the moment, you might put a bookmark in it, and then you'll put it in the bookshelf. And you can't read it when it's on the bookshelf. You can't even read it when it's on your desk. And similarly, the projects that you're working on, you can only read them in some sense, and you certainly only start to change them when they're in your file system. But on the one hand, you want everything available, and on the other hand, you want a narrow focus. And so it's sort of horses for horses. There's a question from Christopher. Can you compose a new collection by combining different tags? Yes and no. The answer is yes. What do you want to do? And you might, for example, want to say, okay, I want to have a collection that consists of, I've got 20 folders, each of which is a different, branch, each of which has got a different tree. So you can combine trees. You can combine trees into another tree, and you can subset. So you can say, create a tree that contains only these 3 folders. And you can put that in your Git repository, and you can give it a tag, and it will be a very, very efficient operation, because duplication is eliminated. Git is able to eliminate duplication because it's a content addressable store. So yes, the answer is you can combine collections you can combine trees.
Mm-hmm.
And if you've got 2 existing trees, you can combine them with a third. You can create a third tree that has those 2 trees as subtrees. So it might be you've got an input folder and an output folder, and you can create another folder, which is an IO folder that contains both the input and the output. And that's easy, and it can be done programmatically without having to do any of these operations on disk. And as long as those 2 trees are in the same repository, they can actually be miles away, and they can be combined.
Mm-hmm.
Because all you're doing is you're moving references to things, or changing references to things, not changing things.
I'm curious what the particular thing you were trying, what were you trying to do where you found out that you wanted to be able to do this thing that you did here? What were you, like, what was the application that you were trying to solve when you identified this problem and
Oh, okay, so what's happening at the moment is that a lot of stuff for Tech Live is developed in Git, and it could just as well be Python. So you have all these Python developers that have their own Python repositories,
mm-hmm.
and the stuff gets packaged for publication, and I'll look at the stuff that's published. rather than the stuff that isn't published, because there can be differences. What I want is updating CTAN to be as simple as doing a git pull. So I'm the owner of the Wibble package. Mm-hmm. I say to CTAN, there's a new version of the Wibble package. Pull it, please. And they will pull it, and it will simply be there, and nothing will happen until CTAN or somebody downstream from CTAN decides to use that new version.
Huh.
It's just there, ready. And similarly for downloading, it can be pulled by somebody and it's there ready in case you want to use it. Because as a curator, you might say, okay, I've downloaded this new version of the HyperF package. I'm not ready to use it yet, but I'll try it out on some things. So check it out, try it out, and revert it, just as you would with your own Git repository. Mm-hmm. You'd say, okay, well, I can revert it if I want to. So everything is revertible in the same way that Git is. And the sort of the human intervention is very slight, and it's not centralized. One of the things I'm quite keen to do is to break the centralization of CTAN and TechLive to make it much, much more a peer-to-peer thing. And that comes up every day when somebody says, I want help with the problem. And what you really want to do is you want to pull their tech distribution as they've got it, so that you can run the same files and in the same context as they're running them.
So you're thinking that their own local copy of CTAN will have it essentially be composed of a list of tags.
Yeah.
And you could exactly replicate it by pulling that set. And
and the tags can be namespaced. So you can namespace tags by person, and Git allows you to set up connections between repositories in such a way that my tag gets mapped to something else as your tag. Right. So when you push and pull, when you pull from me, you store it somewhere slightly differently from me because you put a prefix in front of it.
Yeah.
So that avoids the possibility of collisions, because tags should never change. When something is tagged, it should never change in a repository. Inside a repository, a tag should never change. You can't stop somebody giving the same thing a different tag. But
at least within your domain, it needs to be consistent.
Within your domain, you shouldn't change tags, because you're supposed to be an oracle of truth. I'm presenting it, on the one hand, I've sort of presented it at a very low level, and then on the other hand, I've presented it at a very sort of high level. A sort of intermediate level is where somebody is running TechLive, but they've had to make some modifications locally in order for their document to work. And they'd like to be able to communicate that document together with the local modifications in such a way that other people can use it without messing up their system. And the way to do that is to create in Git a tree that is slightly different. But because it's only slightly different, the only extra information that needs to be recorded is the difference. And it will be this file here has changed and this file here has changed. And because these two files have changed, the secure hash of the folders going up have changed. But that's all. That's the only extra information you need. And at the top, you get a different piece of information. And that tells you exactly what you need to run this document. And that's using the Git mechanism for mapping things. If you use a different mechanism for mapping names to tags, then it's probably even more efficient. But my first concern, I think, is to get several years of TechLive distributions as installed. We're talking about installed distributions. So get installed distributions for several years in a useful, manageable form in Git, so that you can install a subset from there pretty quickly, both in terms of human effort and in terms of computer time. So if you can say, here's my document, and I don't know exactly what it needs, but this subset is enough, then it becomes at least easier, much easier to deal with, to typeset that document again, because you only have to get 200 megabytes of data rather than 3 gigabytes of data. And you've already got the data. It's just that you haven't put it onto disk so that TechLive programs can run it, read it.
I don't know very much about how Archive manages this, but they have this system where they can compile papers, LaTeX papers for the last 20, 30 years.
Yeah.
And they can replicate the environments that papers were submitted under, and they can track that.
Nelson does something fairly similar. He can tell us how he does it, I think.
Yeah, well, we maintain TechLive installations going back now more than 15 years. And mostly our users don't care. They use the current one, the default one, but we do have documents, sometimes important documents, that have depended on a particular style file that was somewhere in the tree and simply don't typeset properly under more recent versions. I'm dealing with one of those right now, which is our annual report that summarizes our graduate facilities for our students. And I have to use a 2017 file. Now, given enough time, I could find out what the problem is and advance it to the latest level. But for a single document, it isn't worth my spending the time. It's much more important to be able to get the changes in place, the new document typeset and released, and not worry about some obscure bug that may affect only me.
And even if you did want to move it forward, it would be a great comfort to know that you can exactly reproduce it with the 2000 and stuff by providing the same inputs.
Yeah,
it's much easier to fix a bug that's introduced when you've got a sound starting point from before the bug.
Yeah. Now for this particular document, which is released annually, rather than it is kept under RCS control, but when the next year arrives, I simply make a copy with a new directory name with the current year in that name, and then the old stuff is frozen. It would be, I think, just too complicated to try to store the entire multi-year history within a single tree and use check in and check out, because it's, for this particular document, once it's produced, it supersedes the previous ones, and we never have to regenerate them. But we have PDFs for them that are on the web. And if the question arises, well, did this regulation in 2017 say the same as it does today? We can easily check that.
So Git deals with pack files, which are a bit like zip files, but they're content addressable stores. So as long as you trust the secure hash, and we do, once you've got a file, an exact statement, an exact file in one of your pack files, you never need to ask anybody for it again. You never have to retrieve it. So you could store all the files that you've ever used on TechLive to typeset with. And once you throw away the duplicates, it becomes quite a lot smaller. And it just incrementally grows a bit every year because there are new versions of things. But the incremental growth is far outstripped by the growth of storage. So we don't sort of have to worry about that.
This does raise a question, Jonathan. Does Git have a facility where you, say, present it two directory trees, such as TechLive from this year and from last year, and ask it to produce a new repository where all of that's merged and there are tags attached that are properly timestamped and so on? Or does one have to do this manually?
Git doesn't record the date and time of files. It doesn't store that information, and I think it's probably right not to, because predominantly you don't use that information, or you shouldn't be using that information. Git just stores objects in a fairly I'll accept anything way. So you can ask it to store a tree, and then you can ask it to store another tree, and it's got both those trees. And if two of the trees, if the trees have got identical files in them, the identical files are stored only once.
Okay. So this would in fact work for successive TechLive years.
Yeah. Yeah. It simply, you throw away the duplicates. It's like a stamp collection. Mm-hmm. Throw away the duplicates.
Yeah, or like file systems that detect duplicate pages and files and share them.
Yeah, there are these deduplication systems that are used to condense storage. So it's a form of that. I mentioned earlier about higher level things. I mean, my view very strongly is that at the lowest level, there are your text files, your blobs. Git calls them blobs because it can't look into them. They're opaque. It doesn't know if they're C code or Python or XML or whatever. They're blobs. And then everything else is built upon that. And the first thing that's built upon that is trees. So once you've got trees, you can sort of recursively build whole things. And then the next thing that's built upon that is commits. So a commit is a tree plus commit information, which is a message and an author and a signer and a date and a time. And it also has parents. The commit has parents. It might have no parents, which is what I was talking about, the orphans. It could have multiple parents. But that is all higher level information that is related to the provenance of the files rather than the content of the files. And mostly when you're using the files, other than as a developer, you're only interested in the content. You don't look at the provenance. But when you're a developer, you're very interested in the provenance, and you want to say, oh, that was so-and-so that did that. Who wrote that line of code? We know who to blame or praise.
Yeah, and I mean, as Git bisect does, sometimes something changes and you want to say, well, which of many changes that were made caused the difference in the output? And so Git bisect automates the procedure of finding out which of the changes was the cause of the problem. And that I think is extremely helpful for developers in big projects.
For developers, extremely helpful for developers. But with tech, one of the big challenges and opportunities and selling points is identical outputs from identical inputs. And in a certain sense, throwing away the metadata, such as the commits and the dates and the times, is actually a simplification of the inputs, which makes it easier to guarantee that you're going to get identical outputs from identical inputs, because there's less to worry about. If you're waiting for a bus and you want to know when the bus is, and you look at the timetable, you're only interested in the timetable. You're not interested in the history of the timetable. Mm-hmm. You're interested in yesterday's. There's a joke, by the way, it's very nice. Somebody a long time ago was driving in the back roads of Ireland and stopped at a shop for some reason, went in and said, "Oh, have you got the newspaper?" He said, "Yeah, we got the newspaper. It's yesterday's." Oh, sorry. Yeah, I've got the newspaper. Do you want today's paper or yesterday's paper? Well, the person thought for a second, well, I want today's paper. And so the shopkeeper said, "Oh, in that case, you're better off coming back tomorrow." the papers don't arrive until the next day. One place I know of, they don't allow Git to be used. They don't allow Git repositories to appear in the demilitarized zone where things are deployed, because they contain history, and that history might leak information. Is just another thing to worry about. And so they won't allow you to clone your Git repository into the demilitarized zone, which is right up to a point. The answer is that you should be cloning a special Git repository that contains nothing except the stuff that you're willing to share, because then you've got Git as a tool that you can use to check whether any of those files have changed, and you can use Git to bring things up to date and so forth. So, but that, I think, was part of my thinking about making Git, using Git as a file system. Git as a large amount of the strength of Git, and for that matter, GitHub, is the content addressable store that Git is, which means that everything's got a secure hash, and that secure hash can be any tree of files that you care to deal with. And you can give that thing a tag, and then you can refer to it by that human name. And that by itself is already immensely powerful. It's already the whole of CTAN. Because if you want to clone the CTAN repository, you just pull all the tags and you get all the stuff coming with you. And the transport mechanism takes care of it for you very efficiently. And similarly, if you want to ensure you get the same inputs, you want to keep a record of the inputs, you tag the tree that you used. And as long as you can dereference everything, you've solved that problem. And that's not using version control at all. You're just using trees and tags. So any one of these things that have got these long identifiers that must be surrounded by quotation marks can be tagged. And then you can say, here's the tag. And it's fairly easy to check that the tags haven't changed.
Yeah. And of course, underneath, many modern file systems really do have something like that going on, that your file is represented as a stream of blocks on disk, but in reality, it isn't just your data that's in those blocks. There are also things like checksums and pointers and so on. And all of that is hidden from you quite conveniently, so, but helps to keep the file system reliable and healthy. And importantly, also allows snapshotting. And so we've been using the ZFS or ZFS file system now for more than 2 decades, and we rely heavily on the capability of doing snapshots. So for us, a nightly backup isn't copying hundreds of terabytes of data to a remote system, but it's rather using the snapshot capability to identify the blocks that have changed since yesterday, and that snapshot gets sent to a remote server. And so it completes relatively quickly. But it does mean we can now go back and, for us currently, about 5 years, and say, what is the state of that file on any day in that 5-year period? Just the day before yesterday, I had to recover a rather large, roughly 100 gigabyte file that an operating system upgraded had effectively corrupted. So I just backed up to before the corruption, brought in the old image, and I'm back in operation. So it's extremely useful. It was much, much faster than having to reconstruct that large object.
Yeah, solid state disks do something similar. They actually move data that hasn't changed about sometimes, because they do what's called wear leveling. Solid state disks sort of wear out in a way that's rotating disks don't. And if a particular, so to speak, part of the disk gets quite busy, it can wear out before anything else. So to forestall that, they sort of say, hey, stop wearing the Shane cert 3 days in a row. You wear this one instead.
Yeah. And speaking of solid state disks, there was an interesting news item on Google News last week that one of the semiconductor manufacturers has demonstrated in the lab a modest sized storage device capable of holding roughly a petabyte of information. And the suggestion of the article was that just within a small number of years, a one-digit number of years, these could be accessible on the market. The other interesting thing was another report on Google News of some French researchers who have transmitted over a reasonable distance data at more than a petabit per second, which is roughly comparable to the worldwide traffic of the internet on a given day. So that also bodes well for the future. So it's really lovely to see these technological developments happening that will remove these boundaries that most of us have spent our lives fighting. I mean, an old friend of mine who managed computing facilities for many years said the standard answer from users about how much disk space they need is one word: more. And if you can store it efficiently, then there's no reason why you can't give them a history of everything they've done for many, many years.
I think my next step is to do something more substantial as a proof of concept in terms of creating a version of TechLive that sits in Git, which is sort of loose leaf rather than bound. Loose leaf TechLive.
Yeah. And presumably at some point, the KPath search library that TechLive software uses to find files in this large collection could be tweaked, probably with relatively minor changes, so that when it receives a request for a particular file name, it could refer to a Git repository elsewhere to find it if the content wasn't local. And that, of course, would mean that you could have just a skeleton of TechLive installed locally, and then as you need new files, they'd be fetched automatically and cached on your system.
Yeah, assuming you've got a network connection or right. Connection to the resources, they don't have to be immediately to hand. But
given that worldwide people rely on these little pocket devices, everybody these days pretty much does have a network. It's true that in developing countries and rural poverty areas and in the modern world, the connections are less good, but they're getting there faster and faster. The United States has just launched a major effort to radically improve internet service to the Indian reservations around the country, because they've been really at the bottom of the heap in terms of getting good service. The largest reservation in the United States is the Navajo Reservation, which is primarily in Arizona, but stretches into New Mexico, Colorado, and Utah. And there are people there that still do not have electricity or running water or telephone service, but they're soon going to have internet service.
I think at that note, I'm going to pause or stop the recording.